Hello, and welcome to Hyperefficient startup number 7. Um, so it's a really weird time when a technical person stops being technical person and starts being business person again. Gladly, this is not the first, the third, the fifth, the whatever rodeo for me. I had to do it in 2012 when I was starting a career of an independent consultant. I had to do it, before 2015 when we started Circle. I tried it here and there in the meantime with some of the attempts that we were doing together with Arseni, which is the co-founder, who is the co-founder of Circle. When it came to trying to do lean startup, which
welcome to Hyperefficient
it didn't
Startup.
quite work out. But I
Episode
was
8,
continuously thinking
also
about
known as
business
episode
and what to
7.5.
do as a
Please enjoy it. It was recorded
as a
yesterday,
business person.
but no one has to know.
And of course, it works out reasonably well for me for the time being. So it's not my first rodeo by far. But it's still, every time you make a switch, my GitHub has like 760 commits in the last 365 days. I don't know if it's a lot or not, but it's certainly more than any of my employees. Let's put it like this. So overall, it just feels like a huge gear shift. It's like it's not even gear shift. It's like you change the vehicle kind of thing. I had some fun during the weekend with coding a system for that can be used for presentations that basically synchronizes the streams of two clients, right? And it also has the chat feature, so it's kind of like those YouTube watch party websites that you have, except it uses the media hosted locally. While working on it, I actually found that was a double trouble there. I actually found an interesting service because of course initially I wanted to be maximalist and just implement it using a WebRTC protocol, so that there's no so that the server just facilitates P2P connection between like the nodes, and then the nodes kind of stream the content between each other, and this way I would be able to say, okay, I want to share this file with my friends and we like watch it together, or with my business partners, or with my customers, right? And it's like it's in sync and blah blah blah. And when I was investigating how to do it, I found this, which is a Banga. I don't know if it's I don't know if it's gonna work, but I made it work locally. So basically, what the fuck is this? It's like it's a system which facilitates everything: chatting, sending messages, video and voice calls over WebRTC. So it's completely not mirrored or the data, not even encrypted data ever touches servers. And you can also self-host your own instance of Chitchatter. So my plan, I was implement the sort of video synchronization tool myself. My plan B was to say, okay, I'm just gonna patch Chitchatter, but I read the source. It's okay. It's very Java-esque, which is fine. And it's written in React and TypeScript and everything we'll know and love, which is also great. but I realized that I'm kind of missing architecture, and I figured, okay, I can spend like an evening learning architecture, or I can home roll Socket.io solution that uses the server to actually do parts of state management that is non-trivial to do over WebRTC, which is something that I've done. I'm not gonna demo it. I'm not gonna leak the URL because, in part it's an internal tool, and in part it's awkward because there is no authentication right now. So the authentication is like basically HTTP pass over SSH, over TSL, but it's not horrible, right? Like you still need to have no shared secret. But the problem, of course, is that when you have access to the shared secret, you have access to the room, and even though there is like presence information, so you won't be able to spy on us, it's still suboptimal. I do have it hosted on my personal GitHub, and I think README is like empty. But yeah, this is a banger. It's like I really like how it worked. And obviously not C4 commits. A bit clownish, but whatever. Yeah, like app is like a router. I experimented a little bit with non-JSON based router this time. And then the bulky component is chat, which is also like under 200 lines, which is pretty nice. Yeah, this is fucking horrible. I want to make it less horrible, but it is what it is. I asked AI to make a responsive UI, which kind of didn't work out. I think that I spent more time debugging the flexboxes that AI made for me than I would spend on projecting or on like architecturing these boxes myself and like writing the code. There was one good thing about using AI though, is that I didn't really know how I will. So obviously, when you synchronize media, right, you want for media to be dominant in the screen on the screen. So I wasn't entirely sure how I'm planning to do that. So I basically just asked it to make flexboxes first, and then I figured out how to do it, and then basically it had to do some refactoring, and I think that for me it would take longer time to refactor, but I also think that the correct strategy would have been to make a chat, then like throw away the class names for the chat components, because chat components really don't change, right? Semantics of the chat components are the same if you display them from top to bottom, like user list, message list, input box, or if you do the flex grid that spans the whole screen, right? Semantics are the same. So I would just discard all the class names, I think, and kind of thought about, okay, when I'm introducing this like pinned media message component, how do I actually change the class names of the existing components for it to fit in? I think this is a healthier way to approach it than trying to squeeze performance out of AI. And actually, the more I interact with AI, and it's like, of course, I can gaslight myself that AI is great and it's just I'm a shitty prompt engineer, but I don't think so. I think that AI is just generally can do stuff to precise specification, but and this is why Copilot is great. You can precisely stipulate that, okay, that this code should be doing these things under those constraints, right? And then it will create a snippet, and then it's very easy for you to also conceptualize what this small snippet does and to accept or refuse or try again. When we're talking about GPT-4o, it's just cringe. It just spits out a lot of code, and then it kind of works, but also really doesn't. It's like it's important to anyone who was doing computer programming knows how much impact a little thing can have on the behavior of the system, of the software system. And like whenever you copy paste code from 4.0 for GPT 4.0, you are creating many of those small things that will, backfire at some point in the future, and you're lucky if they backfire straight away. And types can't save you. The GPT is very good at also glitching types. And I'm not, obviously everything should be typed, right? Just so that we're clear on that. It's just I'm saying that the bugs that GPT creates are superseding, so they're also preserved at type level, right? So GPT is good at writing bugs, both on at type level and at value level, if that even makes sense. I mean, depend on types. Boo hoo. Yeah, there's not much to tell really. Like I made this thing. So I've talked on an impromptu during an impromptu video that I decided to, I think, release publicly, about kind of the philosophy and the mission of Zero HR, where I was answering a question from our marketing expert about the positioning of Zero HR mostly, and then its vision and mission. As I already said there, we have this initiative called Ships in a Dockyard, and I realized the following thing today actually, that currently we have this 10 evaluations, up to 10 evaluations for like 1.2k euro as a baseline offer. And this is in batches, right? So you go like 15, you pay 2.4. And then we have another one and another one. And so the source for this is our basic test tasks. And it may sound basic, but actually these test tasks are pretty interesting. We both have single player for Rust, Scala, and we have multiplayer for Unity 3D and Elixir. Well, actually our own fork of Elixir called Golang. You can laugh now. It's okay. No, nothing. Tough crowd. So those are called basic test tasks because they're like kind of the first ones that we made. Blah blah blah. Unity 3D is like anything but basic. It's like a full-blown game with like strategy and shit, where you have to write AI that kind of works over the wire. Actually, maybe I have a demo. Yeah, it's kind of like this. So you have like these cubes, and they're fighting opponents' cubes, and you have to like write an AI that or a bot, a multi-agent bot that that wins the game, that wins games. Cool. So but obviously all of this stuff, like actually both this stuff and this stuff, is extremely portable. You can port it to other languages, and actually this is the thing that we have done with Rust to Scala. So we had a prospect who was hiring Scala developers, and we were like, we can just port Rust a test task for you, and they were like, yeah, sure, we'll try it. And then they disappeared because that's life. But anyway, our second offer is a bit better. value, but it's delayed. The fulfillment is delayed by a month, right? So this is hire now, and this is in 1 month. And in 1 month, they get to choose, basically, you get 2 hires in a campaign that spans for up to 2 months. So here you can test as many candidates as you want for 2 months for the same price, right? It's the same price, 1.2k euros. And the idea here is that you have to tell us 1 month in advance so that we get to we get to port any stack to we port basic to any stack to be used in this one, right? And all of this is called our basic test task, right, is ship in a bottle, because what we do is we take industrial reality, then we model it to some tiny artifact, then we turn it into a test task, and then bish bash bosh, this is your basic test task. And an initiative I have is ship in a dockyard, which is we take an idiomatic system that uses all the best practices for the stack of the stack of the interest, right? And then we do all of this work inside the system itself. So we find an interesting spot. We turn it into a test task. And this whole thing is your dockyard test task. And here the offer can be the same. Well, actually, no. The important observation, sorry for saying that, important observation here is that the offer here cannot be the same, because there is no porting anymore, right? For every stack, this job will be performed from zero, right? And there is an uncertainty in how hard it will be. So probably the offer here will be so here for dockyard, probably the offer will be the same batch offer will be for 1.2, and this, like, to compensate for uncertainty, I think 2 by 2 will be like 2.5 or something like this, or 2.4. And I'm not sure about 1 month or 2 months here. I think 1 month is good, but it means that when we will be getting customers for this option, I will have to overwork. By the way, this is how this stuff looks. I forgot that on OBS in my pretty faces in that corner. So a thing I worked on today in regards to this idea, ships in the dockyard, was a realization that instead of looking through MIT licensed popular and great repositories on GitHub, this frame instead can be the dream of shitty employers. The dream of shitty employers. This can be their actual system, right? So the dream of shitty employer is you give a test task to a candidate, and this test task is straight from your issue tracker, yeah. But here we freeze their system, then we create a replicable test task that is indicative of what the candidate will actually be doing at their workplace. So there are a bunch of technical kind of aspects of this thing. Like, for example, we have recently Ilona, our employee, has amazingly nixified both single player and multiplayer for making Docker containers. So we were using Nix expression that was generating development environment, right? We weren't building. Well, we were also building, but we were building. It wasn't necessary for us to build with Nix, right? We created the reproducible development environment, and then we could compile. We could compile like in the shell hook, whatever, yeah. And then we would put a Docker over, over this Nix expression, right? And we would have a script that says, okay, like copy all the files, and bam, this is already where your layers are done, right? Absolutely done. You can have import NixOS, good layered cached, copy dot/app, bam, your layers are done. You can't cache anything else. And if you install dependencies after you do copy dot blah blah blah, then you're fucked. I'm sorry for my language, because now every single invocation of your test task, every single build of a Docker image, rather, not an invocation, every build of the Docker image involves rebuild of all your toolchain, which is okay. Like, we launched with this. This is a very recent development when we moved from Nix feeding into Docker to Nix Docker creating the Docker images. And by the way, look into Nix Docker. It's not that hard, and the outcome is amazing, because now everything is layered. Every single Nix expression is layered. So our build times went from dozens of minutes to dozens of seconds. It's crazy. It's so good. Anyhow, so the observation that I'm having is that while we have very, very, very tight control over what is happening here, we have no control. Well, we have some control at picking the project. We can be biased towards projects that are nixified as it is, but obviously it doesn't scale with stacks. Like, for example, with Python, the odds that you will have to create a project, create a flake, where you in your shell Nix you like invoke, in your shell hook you invoke virtual env, is like 99%. One package unpackaged in Python packages, you're fucked, right? No one has the time or the energy to package Python packages. If you're one of people who packages Python packages for fun, then hello, Domen. It's been a while since we chatted. Let's have a call. Or if you're in the UK, ring me up. But no, really. So the control is very superficial when we're talking about MIT licensed things. But when we're talking about the customer systems, the probability of them having Nix is 0. Like, no one uses Nix in the grand scheme of things. Of course, a lot of cuties are using Nix, and for me, I hit a project and I'm thinking, oh wow, this is a good project, and of course there is Nix flake, in it. But yeah, in the grand scheme of things, the probability of the orange box being nixified is 0. Sorry, for those who are just listening, orange box is the box that demonstrates a user, so our customer's system, which we use as a base for our quantified test task. And this is why we actually want to preserve the naive solution to building projects. So the one that goes from Nix to Docker. So I communicated this to my employees, and I hope that's understood. Thank you for watching. first part of 7th episode of Hyperefficient Startups, and see you tomorrow with a recording that I made today.